calculator division. And we're considering to do this, we got to think about the division algorithm. So we've got that idea that n divided by m is equal to some number q, remainder, some number little r, which really means that n equals q times m plus r. So we're going to take these two statements kind of together to figure out how to identify on our calculator what q and r are. Now, some calculators have an integer division function, and some do not. I can't remember if Desmos does, but I have a cute little pink Casio I paid like, I don't know, $8, $7 at Bimart for, and it will tell me the remainder if I ask it right. So let's take the 337 divided by 12, which my Desmos calculator writes in fraction mode. Notice it stacked it, even though it shows me that funky division symbol there. I could convert to a fraction, but it turns it into an improper fraction as opposed to a mixed number, which is usually what we're looking for with the quotient remainder thing. So when I turn it into a fraction, I don't see the quotient anymore. When I get rid of the fraction, I see the quotient, right? The whole number part here is my quotient. The decimal part is related to the remainder. Okay, so I'm gonna write this down in my notes and see if I can tease the remainder out of the calculator. So I started with 337 divided by 12, and my calculator quickly gave me the 28, but then it gave me a 0.0, what was it again? 0.83333. 0.83333. I think it gave me that many threes right there. So how do I turn this into the remainder? Well, that gets to my second version here. So if I rewrite this as my second version, I now know that 337 is equal to 28 times 12. I just don't know what that r is yet, but I can figure it out, because if I can just get the 28 12s out of the way, then I can figure out r. Okay. So there's a couple of ways to do that. The easiest way is to just first take the 28 off. So if I just take that, and so on a new line, I take that answer and I subtract the 28. Let's get it out of there. That leaves only the fractional part, that fractional decimal part. So I'm going to do that in my Google calculator for those of you who have different looking calculators. I started with 337 and I divided by 12 and I get 28 plus this crazy decimal. I want to know what the crazy decimal means in terms of remainder. So I take off the whole number quotient. I know that, I wrote it down. So now I deal with this part. Okay, so where did that part come from? Well, if I look back at my notes, that's the result of finding that there were 28 12s. I just got rid of the 28, now I need to get rid of the 12. Now the 12 got in there because I divided, so to get rid of it, I multiply the 12 back in. And I get my remainder of 1. So in Desmos, I got rid of the 28, but I haven't gone back to the divide by 12. To undo that, I take that last answer and I multiply the divisor back in. And that changes this fraction, which is really 1/12, into the 1. All right, so we'll try that again on another one. Let's come over here to the notes. So here's what happened on the calculator. From the 337 divided by 12, I took away the 28. Okay? And then that left me with this decimal right here. Then what I did is I multiplied the 12 back into that, which leaves the remainder behind, because I took away the quotient and I put the divisor back in. So that's the series of steps. So step 1 on the calculator, divide. Step 2 on the calculator, subtract the quotient. Remember, the quotient is the whole number part of the division. That 28 for us here. Third step is to multiply back in the divisor to get back to whole numbers. Now this is only on calculators that don't have integer division. Some calculators have a button that will automatically say, oh, you want the quotient and the remainder? Here, it's 12 remainder 1. So there are some calculators, you just push a button and it will just say, oh yeah, oops, not 12. The answer is 28 remainder 1. Okay, so we multiply divisor back. And that gives us the remainder. So we're going to check it on another problem. Make sure we all got this down. So let's pick a new division. Let's see, how about dividing by 11? It's not that hard. So suppose we had 1,375 divided by 11. So we'll do this the calculator way, and then we'll try long division on it, or you could try short division if you want to challenge yourself. So 1,375 divided by 11 on a calculator. I'm going to switch back to my Google calculator. So 1,300 and what did I write? 75 divided by 11. So right away I can say, oh, 11 go, oh wow, I got lucky. There's no remainder. Well, that was no fun. Let's make it 77. Oops. Warning, be careful making up math problems on the fly. Sometimes they don't do what you want. All right, now we'll get a remainder. So 377 divided by 11. This should be more interesting. There we go. So we can see it goes in 125 whole times, and then we get this decimal remainder that we want to figure out. So the next step after you do the division is you take away the quotient. The quotient is that 125. And on this calculator, it just holds on to that and lets me continue. So some calculators, once you hit subtract, automatically assume you wanted to use the previous answer. Other calculators, you have to say, no, go get the previous answer. Right? So learn how to use your calculator. So again, on this version of the calculator, after I do my division, I have to go back and say, okay, get that previous answer and then subtract the 125. And I mistyped it. Oops. There we go. Once I do that, I have just the decimal part, and so then I multiply it back by my divisor, 11, and that will tell me what part of 11 that was. So that was 2 out of 11. And here I have to say, get the previous answer, and then multiply by 11. So again, you need to learn how to use your calculator right. So either kind of calculator, once I figure out how to use the calculator to make that happen, I can see that this answer right here is 125, remainder 2. All right, so let's do that with long division just to brush up on our long division. So we want to take 11 into 1,377. And our long division method says, look at the first 2 digits, and 11 goes into 13 once. 1 times 11 is 11. Subtract, and I get a 2 remainder, and then we bring down the next digit. Let's see, 11 goes into 27. How about twice? 2 times 11 is 22. 27 minus 22 is 5. And again, I know I'm doing good as long as that divisor is less than my dividend. The remainder is less than my divisor. So 5 is less than 11, I'm doing good. Provided I didn't make a mistake. Bring down the next digit. 11 goes into 57. Guess 5 times. 5 times 11 is 55. And again, this is contingent upon me knowing some multiplication facts. Fortunately, 11 is pretty easy to work with. And then I get a remainder of 2. And so 125 remainder 2, not too bad. If we were going to do this with the short division, So that's our standard long division. And again, some kids have trouble lining stuff up, and so the scaffold where we put in the zeros could be helpful to them. 11 goes into 1377. So with the short division, I have to think the subtraction. So 11 goes into 13 once. 1 times 11 is 11. 13 minus 11 is 2. And so I just put the 2 right there by the 7. And then I say, okay, 11 goes into 27 how many times? Twice. 2 times 11 is 22. 27 minus 22 is 5. And so again, short division, we have to think the multiplication and subtraction instead of writing it down, which is going to be really hard for a lot of people, but this is ultimately the goal of a lot of countries. They want their all kids to learn short division. And then 11 goes into 57 5 times. 5 times 11 is 55. 55 from 57 is 2, and so we get a remainder 2 there. So that's short division. Oops. Oh, there you go. Here, question?
I did have a quick question on the 1377. If I'm going to put it in the chat real fast.
Yeah.
Okay. Hopefully that went up right here.
Chat.
My brain, yeah, the 1370, is that kind of how we did it last time?
Yes.
And for some reason, this is the computer or the calculator division. Some reason my brain is wanting to do like an algebraic equation and solve for R.
Yeah, and you can totally do that. So I'm gonna write that down. So what Amanda put in the chat was the 1,377 divided by 11 means, once we get the calculator part going, or this part, that 1,377 equals 125 times 11 plus what? And so we can certainly do that multiplication and subtract to get R. So R is going to have to be that 1,377 minus 125 times 11. Correct. And we run through that on our calculator and we say, oh, okay, R is 2. And some classrooms will have sets of calculators that automatically do the integer division. There's ones you could download. So if I did a search, I'm sure we could find one and we could put it on Chromebooks if we needed to, for kids that were having trouble with say, long division and we wanted them to get it done with a calculator. We need that remainder, because there's sometimes we need to know how many are left over, that the answer is let's see, what was this one? 0.18181818. That's not useful sometimes. Sometimes it is, sometimes it isn't. Sometimes it's better to know it's 2 out of 11. So again, it depends whether we want the decimal version of the remainder or the whole number version of the remainder. Cool. All right. So I'm kind of curious. Sometimes some numbers cause trouble in division, in particular 0. So just for fun, if I take a 0 and I try to divide by something like 11, the calculator says, sure, that's 0. What if I tried to do 11 divided by 0? The calculator says undefined. Interesting. And another way I could use 0 with division is 0 divided by 0. And the calculator again says, undefined, don't like that. What does Google say about those? 0 divided by, let's do 7 this time. 0, that's cool. But 7 divided by 0, ooh, Google says infinity. That's fascinating. Huh, to think about that. And then the other one I tried was 0 divided by 0, and Google just says error on that one. Interesting. So Google treated 7 over 0 different from 0 over 0. Desmos treated them the same. I think we need to investigate this a little more closely. So why is that undefined or an error is what we need to analyze here. And so the first one's pretty straightforward. These are division properties for 0. So division property of 0. And there's basically 3 cases here. Okay, so case 1. Is 0 divided by a number that's not 0? So let's just take a slightly easier version. Let's do 0 divided by 2. So we have a couple of different models for what this means. It could be the groups in. So this would mean which how many groups of 2 are in 0. Okay, so here's a group with nothing in it. How many groups of 2 are in there? There are no groups of 2. There are 0 groups of 2. Right? The answer is definitely 0. There are 0 groups of 2 there. And you could use any of the other models to come up with 0 as the answer. Case 2 would be some non-zero number divided by 0. So a non-zero number divided by 0. So that would be like 2 divided by 0. Okay. So if I use like the groups in approach, like I did with the last one, that would mean how many groups of 0 are in 2 or are in a group of 2. Okay. Well, let's get a group of 2 things. Here's 2 x's. How many groups of 0 are in there? Well, here's a group of 0 right there, and here's another group of 0, and there's another one, and there's another one, and there's another one, and another one, and another one, and another one. I could do this all day. Right? I can't answer this question because there's lots of groups of 0 in there. Right? As small as I can draw a little group circle, there's another group of 0. Okay? So this is not answerable. And somebody might say, oh, well, that's just not answerable by that model for division. Why don't you try a different model? Okay, I'm going to try a different model. So the other model we had was the subtractive model. And in the question that one asks, oops, let's use a different color, red maybe. How many times can I subtract 0 from 2? So to get close to 0. So how many times can you subtract 0 from 2 to get close to 0? And remember, we did that with 15 divided by 8. We were able to subtract it 3 times. That left 3. That was as close to 0 as we got. Now here, I get 2 minus 0 is 2. I'll do it again. 2 minus 0, oops, is 2. Do it again. 2 minus 0, messing that up, is 2. And this is going to go on forever, and you're never going to get any closer. That's a problem. And I don't know if you noticed when I did this in Google, Google gave me a strange answer for 7 divided by 0, but I'll do 2 divided by 0. It said the answer was infinity. And given those 2 models I just tried, this how many groups of 0 are in a group of 2, there's infinitely many groups of 0 in there. I can do that forever and ever and ever. How many times can I subtract 0 from 2? I can do that forever and never get closer to 0. So in some sense, Google's right about that infinity. There are other ways to think about it that leads to infinity as the answer. Infinity is a weird idea. Here's, I think, the best reason why you can't divide by 0, and that's by using that missing factor model. Okay, so using the missing factor model, and I'll just remind you of what that was. Missing factor model, let's say for 12 divided by 4. So 12 divided by 4 equals what? We translate that backwards as multiplication. What times 4 is equal to 12. And then we can say, oh yeah, 3 is got to be the number. So let's try that with the 0 problem. So 2 divided by 0 equals what? Translates, read it backwards as multiplication, what times 0 equals 2. Well, let's see. 2 times 0 is 0, so that won't work. 0 times 0, that's 0. 4 times 0, that's 0. There's no such number. And Google, let's see, it wasn't Google, it was Desmos said the answer to this was undefined. Because we can't define a number that makes this work. Anything times 0 is 0, never 2. Okay? And so that's why this is often called undefined. If I try to take some non-zero number and divide by 0, there's no multiplication that works. We cannot define any way to make that work. It's just undefined, there's no answer. Okay? So in this case, undefined, there is no answer, no quotient. So again, I think that's the easiest approach. If somebody tried to argue that you can't divide with 0 at all, I could show them that that's false with the missing factor model. Like go back to the 0 divided by 2 equals what? So missing factor model says rewrite it backwards. What times 2 equals 0? Well, I think it's pretty clear that the answer there is 0. 0 works fine. 0 times 2 is 0. So I can have 0 as the dividend, that's okay. When it's the divisor, I have a problem. So that brings me to case 3. So if somebody could tell me what their favorite number is. Come on, somebody out there's got to have a favorite number. 27, thank you, Julian. That was exactly what I was hoping to hear. Did you know that 0 divided by 0 is equal to 27? Because 27 times 0 equals 0. Oh no, I'm sorry, Amy was right. Amy is really right. 0 divided by 0 is equal to 2 because 2 times 0 equals 0. Anybody else have a favorite number out there? I like 7. I was pretty fond of 7. So Amy, you're wrong. Never mind. 0 divided by 0 is 7 because 7 times 0 is 0. Now this is a problem because there has to be a unique answer. No, no, no. There has to be a unique answer. So since we don't have a unique answer, there's just no answer, right? This, if you plug that into a calculator like I did a minute ago, sorry, Julian, didn't mean to ruin your day there. 27 is a wonderful number in other ways. It's a perfect cube, for example. 2 is the first even prime number. Turns out it's the only even prime number. Every number is pretty awesome, but 2 and 27 are special today. So is 0. So 0 is trouble if it's in a denominator. If it's in the numerator and there's no other 0, we're okay. Okay. So just to summarize, we've got 3 cases here with 0. Something like 3 divided by 0, that's okay. That's 0. Something like 0 divided by 7, that's a problem. We usually call it undefined. Google called it infinity. Undefined. And then the third case is 0 divided by 0. Sometimes that's called indeterminate. There actually are possible answers, but we have no way to determine which is the best answer. Okay, so, but sometimes we call it undefined. And like Google said, sometimes they're just going to call this infinity, which that's cute too. Okay, I think those are the main things I wanted to go over on division. Let's take a look at the activity. And then a brief bit about exponents. And then, let's see. So most of section 3.4 reading assignments due tonight. If you didn't already do it, I saw a bunch of people already did. Please get that done today. The first set of homework is just on division. If you have trouble with any of those, hit that message your instructor and I'll write back to you, or we'll go over it in class on Wednesday. The new activity, has anyone posted? Oh, no one's posted yet. Okay. All right. So this is based on the two of the models we went over. We went over 3 or 4 different models. So remember, a model is a physical explanation / illustration. And on any of these activities, I'm usually looking for pictures and explanations. So if you have explanations and no pictures, you only did part of what I was hoping for. If you have pictures but no explanations, you only did part of what I'm looking for. So here we're going to explore the set partition and repeated subtraction models that we talked about in class today. They're also listed in the book. So here I have a picture of what 6 divided by 2 means for the set partition. The set partition means to make 2 groups and then put six things equally in those 2 groups. And the story I came up with for that was Gary has 6 quarters and wants to use the same amount today and tomorrow. How many quarters will he have for each day? And so this shows that he will have 3 quarters for each day to use. And so then I summarize it down here after I wrote my story and drew my picture. So this is a picture of the set partition. Here's a story related to set partition, and here's my statement about it after. This is the repeated subtraction. How many times can I take 2 away from 6, right? How many groups of 2 are in 6? Now that's a different picture. It's got to be a different story. Now, although I still have Gary in 6 quarters, I changed the story. Gary has 6 quarters and wants to give 2 each to some of his friends. How many friends will get 2 quarters? So I can see 1, 2, 3 friends will get 2 quarters each. So here's a picture that 6 divided by 2 has to be 3, but it's a different picture than the set partition. So this is kind of related to, remember when we did subtraction and we had the takeaway version of subtraction and we had the compare version of subtraction. They lead to slightly different pictures and they have different stories. And I'm going to go over that one again on Wednesday because half the class had a hard time with the pictures and the stories for takeaway versus comparison. So we'll come back to that. In section 3.4, they talk about the set partition, the sharing concept, which I talked about, and then the repeated subtraction, which they called the measurement concept. And they gave an example in the book for 42 divided by 3, so slightly bigger numbers. I gave 2 examples for 6 divided by 2. In the book, they have a set partition example for 42 divided by 3. They have a repeated subtraction for what 42 divided by 3 looks like. What I want you to do is go with that, and I would like you to create a story for 48 divided by 4. So what's going to happen is you're going to have a set partition story for 48 divided by 4, and then you're also going to have a repeated subtraction story for 48 divided by 4. Right? So my stories for set partition versus repeated subtraction were slightly different. Right? Gary was using 6 quarters 2 days in a row, versus Gary wants to give quarters to 3 friends, to 2 quarters to each of some friends. How many friends are there? So I have 3 groups of 2 versus 2 groups of 3. and there'll be a similar thing for 48. The pictures will look slightly different. The stories will have to be slightly different, even though they're both going to have the same answer. So I'm looking for a story and a picture for set partition, 48 divided by 4, a story and a picture for 48 divided by 4 using repeated subtraction, which the book also calls the measurement concept. Okay, so that is your goal. I would recommend trying to get that done by Wednesday before class, so we could talk about it in class some more. What do I have the due date set for it now? I have the due date as Wednesday. Good. All right. Today's the 16th. Yes. Okay. So you have till Wednesday night to get it done. It'd be a good idea to start it before then. Once you post yours, then you can see what other people wrote for pictures and stories. When you do your post, I'm going to go jump into student view. This is a little bit different than the other editor we use, but it's similar. So I start by hitting reply. If I have pictures that I took with my phone that I want to put in here, the way to get them in here is if I took it on my phone, I would have to then like email it to myself to get it to the computer. If you use something like the toys online, you could do a screenshot on the computer. Try to avoid taking a picture with your phone of the computer. Those generally don't look good. But if you have an image on your computer, you just click the embed image button here, and then you switch over to Canvas, My Files, and that allows you to upload any file you want from your computer. So then if you have a good picture that you want to include, you can go grab it. It'll give it alt text, which is the name of the file. It'll tell you how big the file is. So this is 1,920 pixels wide. That's the width of my entire screen. I have a pretty wide screen. That's probably too big. I might want to make it like 500 wide, and it'll adjust the width for me. And then you can just update, and it'll throw the picture right in there, and then you can write around it. I have 2 groups of Earth. Sorry about that, Earth. You can embed pictures directly in there. If you like doing your work in like Google Docs instead, that's totally cool. Just go get your URL to your Google Doc and throw that in here. And then you want to make sure that anyone with the link can view it, so that if other people in the class and me want to see your work, they can click the link and we'll be able to actually see it. Or you could just put your stuff right in here. So that's an option too. Okay, questions on what I'm hoping for the activity and how it's a little bit different, but not much than previous ones. It's the same in that I want pictures and explanations and a story. It's different in that it's going to be in a discussion board that everyone can see, but you can only see other people's work once you've posted yours. So it'll look blank until you put a reply in, and then all of a sudden you'll see whoever else is there. If you see nobody else, that means you're the first, and that's okay too. Questions? Okay, so I'm just going to make a brief mention of exponents and the order of operations, and then we are done. Oops, that ended up in the wrong spot. Oh, so did a whole bunch of stuff. Fix that later. Okay, so exponents. Basic definition of exponents is repeated multiplication. So for example, 2 to the 3rd power means to take the base, which is the 2, and write it 3 times. Oops. 2, 2, 2, and then we multiply. Now we often misstate what an exponent means. We say it's how many times you multiply, but that's not true, because here 2 times 2 is 4, that's 1 multiplication, times the last 2 is 8. I've only multiplied twice to get the 8. So the exponent is the number of times you write the base. then we multiply. Exponents have a slightly broader view than that, but that's the basic view we need to know for now. And later I'll talk more about a broader view of exponents. But just that basic idea is the first thing I wanted to get across. Next thing is how exponents fit into the order of operations. And we'll play with this more in the next class. In case you forgot, the order of operations has kind of sort of 4 steps, okay? The first step is, we say parentheses. And what we really mean there is inside the parentheses. The second step is exponents, and that one's pretty straightforward. The third step, I found I was misled when I was a kid about this. Usually it's stated as multiplication and division. But really it's multiplication or division. And the catch on that is you got to do it left to right. Multiplication does not come first necessarily. Okay, so it's multiplication or division left to right. So if there's a division on to the left of multiplication, you got to do the division first. And somehow I missed that when the teachers talked about it. It wasn't obvious to me. Maybe they said it and it went over my head. Similarly, it's not addition first and then subtraction, it's addition or subtraction. And again, it's got to be left to right. So if subtraction comes first, you got to do it first. You can't go do the additions first. That can mess things up. And what I want to get to next class is why this order. Which once we look at it, it's like, oh, okay, but I didn't think it was obvious when I was a kid. I was like, why can't we do a different order? And I remember my teacher telling me, because I said so, this is the order. Okay, what am I gonna do? You're big, I'm small. All right, so we are out of time for fun with math today. Next class, we will talk about division some more. I'll look at some of those algorithms again. We'll take a look at the models again. We'll look more at the order of operations and exponents. And then we'll have a little time left over to do some review. And the main kind of review I want to do is about the models we've gone over. What does it mean to add? What does it mean to subtract? What does it mean to multiply? What does it mean to divide? In particular, I want to talk about the difference between the takeaway model for subtraction and the comparison model for subtraction, and how their pictures and stories are substantially different, which gets to that activity 3.2b. So in the meantime, you need to get your reading done for 3.4 if you haven't done that assignment. Then there is the automated homework for section 3.4a, which is just division problems. And then there's another homework set that's just exponents and order of operations, and we'll pay more attention to that on the next class. Sometime today, hopefully in the next few minutes, I will post a couple of sample exams down here at the bottom. And then on Wednesday, I will give out the take-home part of the exam. So if you have any questions, hang out and ask them. Otherwise, it was good to work with you today. Sorry you guys didn't get to work much together today. We'll get a little of that next class. Have a great day. You could wave goodbye. Oh, thank you, Evan. You're awesome. And Amy, always nice to see your faces. No people.